The velocity time graph below shows the velocity of trolley X before, during, and after the collision with trolley Y. Calculate the average net force that trolley X exerts on trolley Y during the collision. Usually, the first step to solve complicated questions in physics is to draw a diagram or an image. A diagram with all the information which were given in the preamble of the question or calculated in the previous sub-question is displayed on the screen. Net force can be calculated by using any form of the second law of motion. Even though the formula Fnet is equal to mass times acceleration can be used to solve this question, in the exam memos for the topic of impulse and momentum, the formula Fnet times delta t is equal to delta p is used as the first option. Delta p, change in the momentum, can be expressed as mass times v final minus v initial. All the information required to calculate the net force is displayed on the diagram, except for the time. The value of the time can be derived from the graph. Objects exert force on each other during the collision, which is represented in the second part of the graph. Collision starts at time equal to 20.1 seconds and ends at time is equal to 20.2 seconds. Therefore, the duration of collision is equal to the difference of these two values. 20.2 minus 20.1 is equal to 0.1 seconds. We can substitute this value in the equation. Delta t is equal to 0.1 seconds. Mass of trolley Y is 0.5 kilograms. Its velocity after the collision is 9.6 meters per second. Before the collision, the trolley was at rest. Therefore, its initial velocity is 0. The result of the expression on the right is 4.8. The net force can be calculated as the ratio of 4.8 and 0.1. The correct answer is 48 newtons. As usual, 1 mark has been allocated for the correct formula. Any of the options on the screen can be written in the exam. 1 mark has been allocated for the correct substitution and the final mark for the correct answer.